This is part 2 of chapter 10. Okay, the prescriber ordered 1/4 strength saline solution, 850 milliliters in 8 hours. The label on the box containing the IV set to be used for this infusion is shown here. Calculate the flow rate in drops per minute. Okay, so what we know is that we're supposed to give 850 milliliters in 8 hours. We need to convert to drops per minute. So if I look at this sheet, where to see? Okay, right here. 10 drops is approximately 1 milliliter. Okay, so I'm going to try to get rid of the milliliters and change to drops. So this is 10 GTT for 1 milliliter. Okay, so in this case, my milliliters cancel out. I'm now in drops per hour. I still want drops per minute. So go ahead and multiply across the top. 850 times 10 is 8,500 over 8 drops per hour. And let's do that. Divide it by 8. And you get 1,062.5 drops per hour. Now we just need to convert this into drops per minute. Okay, so I have 1,062.5 drops for 1 hour. We need to go to minutes. We're trying to get rid of hours, so put 1 hour up here on the top to cancel out the unit. And there are 60 minutes in 1 hour. These cancel. And then if you divide this by 60, you get about 17.7 drops per minute. Okay, 10-8. The prescriber orders 45, this is a dextrose solution in saline to infuse at 21 drops per minute. If the drop factor is 20 drops per milliliter, how many milliliters per hour will the patient receive? Okay, so important stuff. 21 drops per minute. I'm just going to kind of organize the information I have. So that's given to me, that's the order. If the drop factor is 20 drops per milliliter, that would be 20 drops per milliliter. And I'm supposed to get milliliters per hour. Okay, well, let's just do this as a long string. I have 21 drops per 1 minute. I need to be in hours, so let's go ahead and get rid of minutes. So there are 60 minutes in 1 hour. Okay. Now I'm also supposed to change from drops into milliliters. So I'm going to use this. Now they're not side by side, but as long as your unit is in the top on one and the bottom on the other, they're still considered a diagonal and they will still cancel out. So I'm going to put, since I'm trying to cancel these drops, I'm going to put the 20 drops in the bottom and then put 1 milliliter in the top. So what happens with my units are that my minutes cancel and then the drops cancel here. So I'm going to end up with milliliters per hour. Okay, so let's just multiply across the top. We have 21 times 60, which is 1,260. And that's over 20. And this is in milliliters per hour. Now just divide this by the 20 and you get 63. 63 milliliters per hour. Okay. Number 9. The order reads 125 milliliters in 1 hour. What is the flow rate in microdrops per minute? Okay, so what we're going to do is we're going to start off with this 125 milliliters in 1 hour. Okay, now we're going to use, it says microdrops, 60 microdrops is in 1 milliliter. So to do that conversion, we're going to use this. I'm trying to cancel out milliliters, so I'm going to put 1 milliliter in the bottom, and then 60 microdrops in the top. Okay, so my milliliters are going to cancel out. I want microdrops per minute, and right now I have hours. So I'm going to get rid of hours. 1 hour is 60 minutes. Okay, hours cancel. And so now I have minutes, but I have 60 here and I have 60 here, so that's going to cancel out. So I end up with precisely 125 microdrops per minute. Now, this is, something kind of interesting because these 60s are always going to cancel out. So every time, you don't even need to do calculations. If you have milliliters per hour, that's going to be equal to microdrops per minute. You don't need to do any calculations at all. If that's the conversion you need to do, it's going to be exactly the same value because you'll always be multiplying by a 60 and a 60, and those are always going to cancel out. Okay, so number 10. The order is 500 milliliters in 5 hours. Calculate the flow rate in drops per minute if the drop factor is 15 drops per milliliter. Okay. So we are given 500 milliliters in 5 hours. Let's start off with that. Okay. We are supposed to find drops per minute. Okay, the drop factor is 15 drops per milliliter. So if I need to get rid of milliliters, so I'm going to put 1 milliliter in the bottom, and then 15 drops goes in the top. Well, your milliliters cancel out, and so you're going to have drops per hour. We want drops per minute, so let's do that hour conversion there. For 1 hour, and I'm putting that in the top because I want it to cancel on this diagonal, there are 60 minutes. Okay, so our hours are going to cancel out, and we now have drops per minute, which is the correct unit. Okay, so what do I have? Well, let's make this a little bit nicer. Let's reduce. If I take this 5 and I divide it by 5, I have a 1. If I divide this by 5, I have a 3. Right? Okay. Now, this is, if I divide this by 10, I have a 6. If I divide this by 10, I have a 50. Now, I'm probably not done reducing, but at least my numbers are smaller. So let's multiply across. I have 50 times 3, which is 150. And these are drops right now. Over, all I have left down here is a 6 minutes. Okay, so let's do this. 150 divided by 6 is 25. So 25 drops per minute is what we're looking for. Okay, now part B. The nurse checks the infusion 2 hours after it started, and there's still 400 milliliters to be absorbed in the remaining 3 hours. recalculate the flow rate in drops per minute for the remaining 400 milliliters. Okay, so originally we had 5 hours to get it done. We've used 2, so we have 3 left. Okay, this is the volume we still have. So we need to do 400 milliliters in 3 hours. And we're going to follow basically the same math we did here. Our drop factor is the same. So I'm going to do 1 milliliter in the bottom to 15 drops. Okay, and now I've got the milliliters gone, just like I did up here, but I also need to get rid of hours. So I'm still going to multiply by 1 hour over 60 minutes. And then my hours will cancel out. Okay, now I did the cross cancellation here. I'm reducing, but if you don't want to do that, you can multiply straight across. Do 400 times 15, and you get 6,000. And that will be over 3 times 60, which is 180. And this is in drops per minute. So do 6,000 divided by 180. And you get 33.3 drops per minute. Okay, now number 11 is exactly the same as number 12, but without the picture you need. So we'll skip 11 and we'll pick up number 12 in the next part.